So this is the 2015 Junior Cert Higher Level Paper 1, and we're looking at question number 11. Two right angled triangles are shown below. Part A says find the height of each triangle, write each answer in the box below the appropriate diagram. Okay, well, we're looking for the height, which is this side here. So we can call this H in this case. And then over here, this can be, instead of H, we can call it G. So we're looking for H and G. Now, Pythagoras, which you can find in the tables book, states that in a right angled triangle, if that side's A, this is B, and the hypotenuse is C, the longest side opposite the 90 degrees, Pythagoras states that A squared plus B squared is C squared. Okay, so then we're just going to link the A with the H and the G is the A in each case, which will be that. The B value will be these values here, which will go there. And then our C value, the hypotenuse, would be this, 15 and the 3, which will go there. So we have two questions to do. So we're just going to split here. So in this case we have H squared plus 4 squared. The yellow squared and the green squared is equal to the blue squared. So H squared plus 4 squared is equal to 5 squared. And that gives me H squared plus 16 is equal to 25. I can bring that 16 over here, becomes a negative. So I have H squared is equal to 9. So I know that H is equal to plus or minus 3, but because this is a length, I can just say H is equal to 3. So that's my first answer, H is equal to 3. And now for this triangle here, the yellow squared, which is G squared, plus the green squared, 12 squared, is equal to the blue squared. So that gives me G squared plus 144 is equal to 13 squared, which is 169. And then I'm going to bring the 144 over here. It's going to become a negative. So that will leave me with G squared is equal to 169 minus 144. Well, that's 25. So my G value then will be the square root of 25, which is just 5. Again, it's plus or minus 5, but because G is a length, we take the positive value. So there's my two heights. Okay, part B. The triangles above are the first two triangles with sides of integer lengths, where the hypotenuse is 1 unit longer than the base. So integer length is a whole number, positive or negative. So we can see that the hypotenuse is 1 unit longer than the base. 5 is 1 bigger than 4. 13 is 1 bigger than 12. So that's what they're talking about. Part B. Another such triangle is shown on the right. So here we have 9, a base of n, and a hypotenuse of n plus 1. It has a height of 9 units, as we see. Use the theorem of Pythagoras to find the value of n, the length of the base of this triangle. So we've defined n. So again, Pythagoras, which you can find in the tables book, says in a right angle triangle, if you have two sides A and B and the hypotenuse C, well, A squared plus B squared is equal to C squared. That's all Pythagoras says. So again, we've got our A value, which we'll take as 9, our B value, which we're going to use n, and then our C value, which is our hypotenuse, will be the expression n plus 1. So now we're going to set this up. We're going to have the yellow squared plus the green squared is going to be equal to the blue squared. And be careful there, when you're squaring the blue, you're squaring the whole thing. So you want to put it all in brackets like that. So that's going to give me 9 squared, 81, plus n squared is just n squared. And that's equal to n plus 1 by itself is n plus 1. So when we do this, we get n by n is n squared plus 1n plus another 1n, and then 1 times 1, which is 1. So that's n squared plus, you can combine these two here, 1n and 1n gives me 2n plus 1. And again, the left side is not changed, so this is still 81 plus n squared all the way down. So now what can I do? Well, I've got n squared on both sides, so I can just take that away from both sides. And I'm going to bring this positive 1 over here. It'll become a negative 1. So 81 minus 1 leaves me with 80. And that's equal to just the 2n left on the right. So now what I can do is divide both sides by 2. And the reason I do that is because they cancel here, leaving me with n on one side equal to 80 divided by 2, which is 40. So there we go, my n value is 40, and that's what I was asked to find. To find the value of n, which is the length of the base. So n was 40, which means this would be 41, but all they wanted was n. Okay, these triangles can be put in a sequence of increasing size. The lengths of the bases of the triangles in this sequence follow a quadratic pattern. 3 consecutive triangles in this sequence are shown below. So part C says, use this information to find the length of the base of the next triangle in the sequence. Okay, well, if they follow a quadratic pattern, we should know with a quadratic pattern that the second difference is constant. Second difference is constant. That must be true if it's quadratic. Now what that means is, if you find the difference between the first two terms, so 112 minus 84, this is the difference of 28. And if we find the difference between the third and the second term, that gives me a difference of 32. So the second difference is when you find the difference of those two. So there we have 32 minus 28 gives me a difference of 4. Now, because they told us in the question that this is a quadratic pattern, this second difference of 4, which I'm just going to color code here for you, the second difference is constant. So here's our second difference. So that means that if it's constant, if we go to our next difference here, it's still going to be a jump of 4. So that means our next number here will be 28 plus 4 is 32. 32 plus 4 is 36. So we have this number here now. And then if we're trying to find the length of the base of the next triangle in the sequence, if you can imagine we're trying to find this next triangle over here, well, to find that length, it's the 144 plus the 36, just like here was 84 plus 28 is this, 112 plus 32 is 144. Well then 144 plus 36 will give me the length of the base of the next triangle. So 144 plus 36 is 180. So that's my answer. The answer is 180. Okay. Finally, part D says the length of the hypotenuse h of triangle x in this sequence is given by the function below, where b and c are integers. So here's the function h of x is equal to 2x squared plus bx plus c. Also, they tell us that h of 1 is 5 and h of 2 is 13. Use this information to write two equations in b and c. Okay, so we're going to try and use this information here. So h of 1 will be equal to, what we're doing here, just to be clear, we're replacing the x. H of x is 2x squared plus bx plus c. So we're replacing these x's here with the 1 in the first instance. So we get h of 1 is equal to twice 1 squared plus b times 1 plus c. And we know that this is equal to 5. H of 1 is equal to 5. They tell us that in the question. H of 1 is 5. So again, just to be sure there, the 1 got put in there in the position of the x's. So what we have then is we have an equation now here. If we forget this h of 1 now, we have 2 times 1 squared plus b times 1 plus c. That gives me 2 plus b plus c, and we know that's equal to 5. So if I bring this 2 now, bring that positive 2 over here, becomes a negative. I'm left with the equation b plus c is equal to 5 minus 2, which is 3. So there's one equation in b and c. And now I'm going to do the second equation over here using this information here. So this time h of 2. So h of 2 is equal to 2 bracket 2 squared plus b bracket 2 plus c. And this time h of 2 is equal to 13. So again, forgetting the h2 bit part now, we see that 2 squared is 4, and when we double that, that gives me 8. Plus b times 2 is just 2b. Plus c is equal to 13. So when we bring this 8 now over here, it becomes a negative 8. And we're left with 2b plus c is equal to 13 minus 8, which is 5. And that's my second equation in b and c. So I've now done what they asked, used the information to write two equations in b and c. Okay, part 2 says solve these simultaneous equations to find the value of b and the value of c. Okay, so I'm going to write these two equations above each other. So 2b plus c is equal to 5. And the other equation then is b plus c is equal to 3. So if I write them above each other like this, I can see that if I want to eliminate either the b's or the c's, it's easy to eliminate the c's here by just subtracting one equation from the other. So I'm going to put a big minus sign here to represent what I'm doing. Now b here is the same as 1b. So 2b minus b is just 1b, or b. And c minus c, they cancel, which is why I did this. So all that's left then to do is to subtract the 3 from the 5. 5 minus 3 leaves 2. So I have my b value straight away there. There's b value is 2. And now what I want to do is find c value. So what I'm going to do is use this equation here. b plus c is equal to 3. And I'm going to substitute the b value of 2 in here. So that's 2 plus c is equal to 3. Well, if 2 plus c is 3, c must be the number 1. So there's my c value of 1. And that is the end of question 11.